Polar curve given by 3 theta plus sine theta between the angles of 0 and 2 pi radians. In part A, they asked us to find the area in the second quadrant closed by the coordinate axis and the graph of r. Now, this is a calculator active problem, so you should be able to sketch this with no problem using the aid of a calculator, but pretending you don't have one. As theta grows, my radius is going to grow. That's what's happening with 3 theta. With sine theta, at least for a while, the radius is going to grow because sine grows. So in general, we're going to get something that has a radius that is getting bigger and bigger. There's a little bit more to it than that, but it is a graphing calculator question, so you can type in the equation and see that the curve does this. They ask you to find the area in the second quadrant, so that would be the area between angle theta equals pi halves and angle theta equals pi. And our wedges stack up along that way. So in calculating area, we do 1/2 r squared d theta when we're calculating in polar, and in the case of this problem, I'm going to go ahead and put the 1/2 to the front. R is 3 theta plus sine of theta squared d theta. If you wrote it as r of theta, you would have saved yourself time and avoided the problem of accidentally writing the wrong thing down here. So r of theta works. And the angle starts at pi halves and finishes at pi. When it comes to grading this, there are 3 points. You get 1 point for having the integrand correctly. You get 1 point for having the limits and the constant correct. And then you get 1 point for the answer. And because this is calculator active, we type this into a calculator, and remembering that we're in calculus class where we're in radian mode, this should generate an answer of 47.513. And that is your third and final point for part A. For the angle pi halves to the angle pi, there's 1 point P on the curve with an x coordinate of -3. Again, if we picture what this curve looks like, what that sentence is saying is somewhere on the curve, the x coordinate is -3. Okay?
They're right.
Find the angle that corresponds to that point.
It was almost 2 pi.
So
2 pi minutes, but it wasn't.
somewhere over here, and this is totally not scale, it could have been up here, I don't know, because I'm not looking at my graphing calculator. The x coordinate is 3. So somewhere x equals -3. And we know x to be r cosine of theta equaling -3. Well, r cosine of theta would be 3 theta plus sine of theta times cosine theta has to be equal to -3.
It's a little.
Solving this equation, because it mixes algebra with trigonometry, solving this equation by hand is difficult and outside of the scope of the class. So the way we would approach this is we could, with our graphing calculator, one method would be to stick 1/2 of the equation into y1 and the other half of the equation into y2 and see where the two curves intersect. Going through this process on the graphing calculator, we find that they intersect at the coordinate 2.01692. Now keep in mind that's a measurement of radians, so about 2 radians. So again, if you're going to use your graphing calculator to solve a problem, we tend to do that in rectangular coordinate systems. So I have to switch my mode back into a function mode. That allows me to work in a rectangular coordinate system. Under y1, I'm going to stick the first equation, which is 3 variable plus sine variable. And then this whole thing gets multiplied by cosine. So insert a parenthesis times cosine of angle. That equation we are going to set equal to -3. So where these two curves intersect each other is the point where this equation would be true. When I graph when I graph it on the rectangular coordinate system, it's healthy, of course, to zoom to a standard viewing window. Yes, it's healthy. Good for you, like apples. Where does this intersect -3? We see more than one location, but there's probably only one of these that occurs between pi halves and pi, and it's that location right there. So we need to know exactly what that is. So by pressing second trace, we are able to calculate intersections. So we're going to calculate the intersect, press enter on the first curve, enter on the second curve, move your cursor to the desired location, and at x, or theta, at x equals 2.0169, we have the intersection. So the point breakdown for this part B, you get 1 point if you set up the equation, and you get 1 point if you found the value of theta. Now that wasn't the entire question. They also said find the y coordinate of point P. So now that we know the angle that point P is at, our sine of theta is going to be our y coordinate. Or if you're going to, since we've already labeled this number theta, we can just write r theta times sine theta. We don't even need to substitute in, and we get 6.272. By the way, these are approximates because we're rounding. And this last one is worth your third point. So 3 points in part B. A particle is traveling along the polar curve so that its position at time t is given as xt, yt, and the rate of change of the angle with respect to time is 2. They want us to find dy dt when the angle is 2 pi thirds. So again, the meaning of this question is we have this polar curve, and over here, when we get to angle 2 pi thirds, the angle is increasing by 2 radians per unit time. And they are asking us to find dy dt. So kind of like how rapidly is the y coordinate of this point changing. So we can set up a relationship between y and the angle theta. Y is r of theta times sine of theta. Or if you want to substitute in, r is 3 theta plus sine theta times sine theta. Either way, that relationship there. And we are going to be doing a related rates problem on this. So we're differentiating with respect to time. So if I take the derivative of the left with respect to time, I would get 1 dy dt. And if I take the derivative of the right-hand side, I'm going to shorthand this, and I'll explain in a moment. The derivative of the right-hand side would be the derivative of y with respect to theta times d theta dt, because we're differentiating with respect to time. And the question is asking us to find this value when theta is equal to 2 pi thirds. So we're going to evaluate this expression when theta is 2 pi thirds. They give us the fact that d theta dt is 2. So all we need to do is find dy d theta at 2 pi thirds and multiply that by a value of 2, because they provide us this number in the problem. Okay. Well, how do I evaluate dy d theta at 2 pi thirds? Again, we can turn to our calculator and have the calculator evaluate a derivative at a point. So turning to our home screen on our graphing calculator, making sure we're in radian mode, math 8, take the derivative of, and I'm just going to use the variable x, 3x plus sine x, close the parenthesis, sine x, close the parenthesis, at 2 pi thirds. Light on there. Okay. Oh, it's like flickering. Let's not do that.
Recording?
I am. It was? Oh, man. The point breakdown, now that we've established this, the point breakdown. 1 point if you use the chain rule. So if you recognize that you needed to take the chain rule. 1 point if you arrived at the answer of negative 2.819. And then finally, the last point comes from saying that the y-coordinate is decreasing at this rate, for a total of 9 points.